Hey guys, Mr. Fackenthal here. Today we're going to be talking about Chapter 1, Section 2, which is solving multi-step equations. This is a follow-up to solving one-step equations that we did in the last section. Our objective today is that students will be able to solve multi-step equations. Alright, so get that down and we'll move on. Alright, today's key idea is in solving multi-step equations. What we want to do is to solve multi-step equations, use inverse operations to isolate the variable. What do we mean isolate? Well, we want to get the variable, so just say it's x, alone on one side of the equal sign. Okay? Whatever variable we're solving for, could be x, could be y, could be any letter. We want to use our inverse operations that we went over from our order of operations to isolate this variable so we can find out what x is equal to. Alright, so example 1, solving a two-step equation. They give us the problem that the height in feet of a tree after x years is 1.5x plus 15. After how many years is the tree 24 feet tall? So the first thing we have to do is write out our equation. 1.5x plus 15 is equal to 24. We want to know how many years pass for the tree to be 24 feet tall. What this equation is saying is that the tree grows 1.5 feet per year, and it started out at 15 feet tall. So the first thing we have to do is try to isolate x. So we got to subtract 15 from each side. Okay? That'll leave us with 1.5x is equal to 9. Alright, now we have 1.5x is equal to 9. We still want to try to isolate x. So 1.5 is attached to x right now by multiplication. The inverse operation of multiplication is division, so we have to divide each side by 1.5. Okay, when we do that, we get x, because these two 1.5 cancels, x is equal to 9 divided by 1.5, which is 6. So after 6 years, the tree is 24 feet tall. Alright, example 2, combining like terms to solve an equation. So for this one, we're going to have to combine like terms to solve this problem. They give us the problem right here. First step is it's 8x minus 6x minus 25 is equal to negative 35. So the first thing we have to do is write it out. 8x minus 6x minus 25 is equal to negative 35. So the first thing we have to do is combine like terms. Well, 8x and 6x are like terms. So we'll combine them. 8x minus 6x is 2x. There's no other like terms to combine, so it's going to be minus 25 is equal to negative 35. Okay, so we combined our like terms. Next, we want to isolate x. Negative 25 is attached by subtraction. The inverse operation of subtraction is addition. So we add 25 to each side. Okay? We add 25 to each side. These cancel. So it'll be 2x is equal negative 35 plus 25 is negative 10. Then we have to divide each side by 2 because 2 is being multiplied to x. Inverse operation of multiplication is division. So now x is going to be equal to negative 10 divided by 2 is negative 5. Alright, so our final answer is x is equal to negative 5. Alright, example 3 is all about using the distributive property to solve an equation. So they want us to solve 2 times 1 minus 5x plus 4 is equal to negative 8. So let's rewrite the equation first. Plus 4 is equal to negative 8. So the first thing we have to do to solve this problem is distribute this 2 into the parentheses. Alright, we have 2 minus 10x. Alright, after that's distributed, we have 2 minus 10x, and then you just bring the rest out. plus 4 is equal to negative 8. All right. Now we have to combine like terms. So we have positive 2 and positive 4 on this side. We can combine them to make that positive 6. So it'll be negative 10x plus 6 is equal to negative 8. Now we would solve it just like a two-step equation. Subtract 6 from each side. Alright, now once we do that, we have negative 10x on this side, and then negative 14x on this side. After that, we divide each side by negative 10. That's going to leave us with x is equal to negative divided by a negative is a positive, so this will be positive 1.4. Okay, so that's going to be our final answer right here. X is equal to 1.4. Another way we could have solved this equation in example 3 is if we divided the 2 out first. So, so we would have had to subtract 4 from each side. That'll give us negative 12. Then we can divide each side by 2, and that 2 goes away. But as long as you can do it one of these two ways, you're good to go. Alright, example 4 is our real-life application. They want us to use the table to find the number of miles, x, you need to run on Friday so that the mean number of miles is run per day is 1.5. So they gave us this table over here, Monday, Tuesday, Wednesday, Thursday, Friday, and how many miles we ran on each. How many miles do we have to run on Friday so that our mean or average is 1.5? So the first thing we have to remember is, what is the definition of mean? Well, the mean is the sum of all of the values divided by the number of values that there are. So this would be 2 plus 0 plus 1.5 plus 0 plus x all over, there's 5 values, so it would be all over 5, is equal to 1.5. I'll slide this over. When we first we have to simplify, so it's going to be 2 plus 0 plus 1.5, so that's plus 0, so that's going to be 3.5 plus x all over 5 is equal to 1.5. So now we just have to solve. Well, the first operation we're doing here is division. To undo that, we have to multiply each side by 5. Okay? When we do that, the 5's here cancel, so we'll bring that down, so it'll be 3.5 plus x is equal to, this will be 7.5. Next, we just have to subtract 3.5 because we're still isolating x. We have positive 3.5. The inverse of that is to subtract 3.5. So it'll be minus 3.5 from each side. And I'm just going to move this over here so I don't run out of room. So these will cancel. That'll just give us x. And this will be 4. So x is going to be equal to 4. So we would have to run 4 miles on Friday for our mean to be 1.5 miles run per day. Alright, thanks for watching. Don't forget to like and subscribe. Comment below if you have any questions or bring your questions to class. Also, please turn on the notifications when you subscribe, so that way you can know whenever I post new videos and you can be ahead on all of our lessons. Alright, happy solving!